Okay, so when we're gonna, excuse me, graph an equation, there's actually two ways to go about it. I don't think they've shown you the second way yet. I'm going to show you the first way that I know that they've shown you, and then I'm going to show you another way that's equally accurate, but probably a little easier, actually. But I want to stick with what they've been showing you in the video for right now. Excuse me, when we have an equation, if we want to know how to find the points that go on this graph, we need to put in some x's and some y's into the equation and see what gives us a true statement. And I'm going to back up a minute. If we had a problem that said like y equals x plus 2, just something real simple like that. Excuse me. We know that there's certain numbers, like if, let's say if x was a 5. So we would say if in our set of coordinates x is 5, then we know that y would have to be the result of this math. Y would have to be equal to 5 plus 2. So we would say, oh, y, when you do the math, y is 7. So when x was 5, it turned out that y is 7. We could take that same problem and we could say, wait a minute, what if x was a 1? So we'd say y equals 1 plus 2. So, whoops, not with an x, we already replaced the x, okay. So we're saying in our set of coordinates, if x is a 1, what would be the y value? Well, y is equal to 1 plus 2, or y is 3. So it turned out that when x is a 1, 3 is the matching value that made this equation work. So notice in both cases, I chose a number for x. I just picked a number. There wasn't any reason for the number I picked other than I like to choose small numbers because small number math is easier. But I could have chosen any number in infinity and it would have been fine. And I didn't have to choose x. I could have chosen a y value. What if I said, what if y is 10? So I would have written it as 10 is equal to x plus 2. So I'm making the assumption that my y value is 10. And so then I would solve for x. To find out what my x value should be, I'd get x alone. So I'd subtract 2 from both sides. And I find out that when y is 10, x has to be 8 for this statement to be true. So there's a kind of a run through with an easier equation. So let's go back to the equation that you gave me. We can do the same thing. We can choose a value, and we tend to use this chart. This is the same as doing the coordinates like above where you put the numbers in. We just set them up as a little chart to kind of organize ourselves. So up here, if we said, what if x is, we could put any number we want to, or y. And when y is by itself, I tend to like to choose a number for x. And a little tip here for you. If the number that's attached to the x is a fraction, I like to choose a multiple of the denominator because when you do that, it makes the fraction part go away and you won't have an answer that's a fraction. So if there was a 3 down here, I would choose 0, 3, -3, 6, -6, 9, -9, any multiple of 3. In this case, since it's a 5, I'll choose 0 is always a good number to choose, and then 5 and -5, 10 and -10. Those are all good numbers to use for the value of x because when you do the multiplication of that number times the fraction, it will cause the fractions to cancel out, which is always nice for the math. All right, so what if I said x was 0? And then what if I said x was 5? We're going to do both of those problems and see what happens. So if x is 0, then this is what the problem looks like. Times 0 minus 5, because you're going to replace the x value with the number that we put over here. All right, so now follow your order of operations of how to do all math. On this side, we're going to do multiplication first before we do subtraction. So 3/5 times 0, anything times 0 is 0. So that part is 0. And then 0 minus 5 is -5. All right, so now we found out that when x is a 0 in this problem, the number that the value for y is -5. Sorry. So then what if x was a 5? So we rewrite this problem, and we're going to put that 5 in there for the x. So it's going to say times 5 minus 5. Again, replacing that with the number that we've chosen. All right, and then we'll do the math here. 3/5 times 5. And remember, when we do fractions multiplying, we make sure both of them are in fraction form. And then if there's anything on top that's in common with anything on the bottom, we try and divide it out of there. Well, sure enough, if you divide by 5 for both of these, you get 1s. So now we have 3 times 1 is 3, and 1 times 1 is 1. So it's 3 over 1. Any number over 1 is just that whole number. So now this comes out to being just 3 for this part. So now we have 3 minus 5. 3 minus 5 is -2. So y is -2. So it turns out that when we put 5 in for x, y is -2. So there's our two sets of coordinates that we can put on the graph. Okay, so 0, -5, 5, -2. So 0 on the x, -5 on the y. 1, 2, 3, 4, 5 went down here. Didn't make my graph big enough, did I? And then 5 and 5 and -2. 1, 2, 3, 4, 5, and then go down to the -2 on the y. Right there it is. Alrighty, and then we just connect those dots and draw that line. Now, this is definitely any equation that you need to graph. You can make this little chart, and you can choose one of the numbers and solve for the other. You don't get to choose both numbers in the set out of the top of your head. You just choose one of the numbers in the set, and then you put it into the problem and solve it to find the other number. Now, another way, which they're going to be showing you probably in the next section, I don't think it was in this section, so this will be new information for you. But we have this thing called slope-intercept equation. When an equation says y equals, when it's the only thing is the y over here, there's a kind of a faster way to graph it. Whatever number is sitting out here without the x, that number tells you where the line is going to touch the y-axis. It's called the y-intercept. So whatever number's out here, you can actually create the first set of coordinates immediately from that number. You always put 0 in for the x, and then whatever number is sitting here is what is for the y. So 0, -5. Notice that's the same set we found up here when we put 0 in for x. Every single time that x is 0, you will be finding the spot on the y-axis where your line is going to cross the y-axis. Isn't that what happened here? Here's our y-axis. Right here's the spot that this line crossed the y-axis. So the first thing that the equation tells you, if it says y equals, if it has anything else over here, then you can't see that yet. We can make that happen later. But when y is alone, then the number that's sitting out here by itself just starts your first coordinate. Then you can use the slope, which is this number that's next to the x. That number tells you how to create the next point. So 3 over 5, the top number is telling you how to change our y value. And the bottom number tells you how to change the x value of the set that we already have. Remember, this is the x and this is the y. So the top, it's kind of upside down. My brain wants to think of it as x over y, but it's actually y over x. So since this is a positive 3, it's telling me to add 3 to my y value. And the bottom one's telling me to add 5 to my x value to get the next set. So the next set is 5 and -2. That's exactly the same sets we found up here. So let me run you through that section again with another equation. If I have y equals negative 1/3 x plus 2, if I want to graph it, I can make my little chart, and I can say, what if x is 3, what if x is 0, what if x is negative 3? That would kind of work for this problem, and I would solve for whatever these numbers are. However, if you want to, you can do the method I just showed you, and that is whatever number's sitting out here by itself, automatically put it into a set that says 0 and that number. Then use your slope, thinking about how the top number affects your y values and the bottom number affects your x values. So that means that I'm going to go ahead and subtract 1 from y, and I'm going to add 3 to the x, because that negative is only on one number, it's not on both of them. So then this gives me 3, and let's see, subtract 1 from 2 is 1. So for this equation, that's what I'm going to graph, 0, 2, 3, 1. So it would look like this. 0 and 2, 1, 2, 3, up 1, so it'd be about right here. So this line would look like that.